In this example, we're trying to balance a relatively simple chemical equation. Now remember, for a chemical equation to be balanced, the number of each type of atom on the reactant side of the equation has to equal the number of the same type of atom on the product side of the equation. So let's look at the nitrogen atoms to begin with. On the reactant side, the molecule that contains nitrogen atoms is N2. That 2 means there are 2 nitrogen atoms in the molecule. There's no number next to the molecule, so that means there's just one molecule right now. So 2 atoms in the molecule times 1 molecule means there are 2 nitrogen atoms on the reactant side of the equation. Now let's look at the product side of the equation. The product side of the equation has its nitrogen atoms in the only molecule that's over there, NH3. There's no subscript after the N, so that means there's 1 nitrogen atom in NH3. There's no number to the left, so that means there's 1 molecule of NH3. So 1 nitrogen atom in NH3 times 1 molecule of NH3 means there's only 1 nitrogen atom on the product side of the equation. Well, obviously the nitrogen atoms aren't balanced. How are we going to balance them? Now remember, when we're dealing with chemical equations, we can never, ever, ever, ever add, subtract, or change subscripts. Remember what subscripts mean. They tell you the chemical formula of the molecules involved. I could balance this equation by putting a subscript of 2 after the N in NH3, but then the product of the reaction would no longer be NH3. It would no longer be ammonia. It would be N2H3, which is a compound that doesn't even exist. So the subscripts cannot be changed in any way. They have to be the same because they tell you what chemicals are participating in the reaction. We cannot change the chemicals of the reaction, so we cannot change the subscripts in the reaction. Now, although we can't change the subscripts that appear in the chemical formulas, we can change something in the chemical equation. We can change the numbers that appear to the left of the molecules in the chemical equation. Remember what those numbers tell you. They simply tell you the quantity of molecules that are participating in the reaction. I can't change the chemical nature of the molecules in the chemical reaction, so I can't change the subscript, but I can change the number of those molecules that react. 1 molecule might react, 2 molecules might react, 3 molecules might react. Those things I can change. So I've got to balance this equation by changing the numbers that appear to the left of the chemicals in the chemical equation. How can I do that in this chemical equation? Well, there are 2 nitrogen atoms on the reactant side of the equation and only 1 on the product side of the equation. So I need to play with the product side of the equation to get more nitrogen atoms. Let's put a 2 in front of the NH3. If I take that same chemical reaction and simply insert a 2 to the left of the NH3 molecule, I haven't changed the chemical nature. We're still dealing with NH3. We're simply dealing with 2 molecules instead of 1. But now look what happens. The number of nitrogen atoms on the reactant side has not changed. There are still 2 nitrogen atoms in the molecule and 1 molecule, so 2 times 1 is 2 nitrogen atoms. But look at what happens on the product side now. There's still only 1 nitrogen in NH3 because the subscripts can't change. However, I now have 2 molecules, so when I multiply that 1 by the number of molecules, 2, I get 2 nitrogen atoms. The nitrogen atoms now balance. Okay, that's good. Now let's go on to the hydrogen atoms. On the reactant side of the equation, hydrogen appears in H2. That 2 means there are 2 H atoms in each molecule. There's no number to the left of the molecule, so there's just 1 molecule right now. So 2 hydrogen atoms in a molecule times 1 molecule tells us that there are 2 hydrogen atoms on the reactant side of the equation. On the product side of the equation, the hydrogen atoms are in NH3. The 3 means there are 3 hydrogen atoms in each molecule. I put a 2 to the left of NH3. That means there are 2 NH3 molecules. So I take the number of hydrogen atoms in each molecule, 3, and I multiply by the number of molecules, 2, and I now have 6 hydrogen atoms on the product side of the equation. So the hydrogen atoms are not balanced. I can balance those hydrogen atoms by altering a number on the reactant side of the equation. If I rewrite the equation here and stick in a 3 in front of H2, look what happens. If I count up the number of H atoms on the reactant side of the equation now, H2 means there are 2 atoms per molecule, but I've now stated that there are 3 molecules. on the reactant side of the equation. So 2 atoms per molecule times 3 molecules of H2 makes 6 hydrogen atoms. The number of hydrogen atoms on the product side of the equation hasn't changed. There are 3 hydrogen atoms per molecule of NH3, 2 molecules of NH3, so a total of 6 hydrogen atoms. Now the hydrogen atoms balance as well. So we now have a balanced chemical equation because the number of nitrogen atoms is balanced on each side of the equation, and the number of hydrogen atoms is balanced on each side of the equation. So that's our final answer. N2 gas plus 3 H2 gas makes 2 NH3 gas.